Hello everyone. This time we're going through example 9-12. Whoop, got my eraser on. 9-12. Okay, so this one picture is going to be helpful, so I'll go ahead and read the problem and then I'll draw the picture. So a tractor drawbar is connected to an implement as shown. Okay, and I will go ahead and draw it. It looks something like this. We have kind of a fork right here, and we have another device right here, which is the drawbar. And it's connected with a bolt. Okay, bolt goes through, holds the two together. And we have 50 kilonewton force pulling on it. Remember, just because you see two arrows does not mean you multiply it by 2. It's just 50 kilonewtons when we come to calculate our stress. And it's going to ask us a couple things. It says, first off, calculate the shear stress in the bolt if the bolt diameter is 19 millimeters. Okay, so find shear stress if D equals 19 millimeters. And then it says calculate the percent increase in shear stress if the bolt diameter is reduced to 16 millimeters. Okay, shear stress if D equals 16 millimeters and percent increase. Okay, so now first off we need to think. We need to think about, well, what is our surface area in this one? So this bolt, if it breaks, we're going to see new areas of it, right? If it breaks, what we're probably going to see, if I pull this guy right here all the way away, what I'm going to have is I'm going to see the top of this, and I'm going to see the bottom of it. And there's two surfaces that I could not see before. I couldn't see this surface right here, and I couldn't see this surface before. So the area is not the area of one of these. The total area will be the area of both of them because both of them were not there before. So in this case, my area would be equal to 2 times the area of a circle, which is going to be pi over 4 d squared. Okay, now with this, I should have enough to solve my problem. Let's go ahead and solve. So the first step in all these problems is always to write down your equations. So the shear stress is equal to the load over the area. And if I calculate this right, it's going to be 50,000 kilonewtons over the area of 2 times pi over 4 d squared. Which I should, if I'm being smart, would go ahead and put 19 millimeters squared. There we go. Oh, and I actually wrote 50,000 kilonewtons. It's just 50,000 newtons. There we go. And this should come out to be 88 megapascals. Okay, so that's part 1 done. The second part is to calculate it if it's 16 millimeters and see what the percent increase is. Well, let's calculate it. It's the same exact equation with the same exact area. Sorry, not the same exact area. Same exact load, different area, but the same equation. So I plug it in. It's going to be 50,000 newtons over 2 times pi over 4 times 16 millimeters squared. And just like last time, what we get is that the stress is going to be equal to 124.4 megapascals. And once again, just in case you've forgotten or you haven't seen it yet, what I'm doing here to get this straight from newtons and millimeters squared to megapascals is that 1 megapascal is equal to 1 newton over 1 millimeter squared. This is extremely helpful. So use this to your advantage. Okay, now the last thing it asks us for is the percent increase. Now I'm going to actually move up a little bit here. Yes, I can move this around. You didn't realize that, did you? Percent increase is always final minus initial over initial times 100. For whatever it's asking for. Final minus initial over initial times 100. This is percent increase. or percent decrease. It just really depends whatever it's doing. So with this, I know what my final and my initial are. So it'd be 124.4 minus 88 over 88. And what I get is that the percent increase is equal to 41%. There we go. And with this, I solved the problem. So you see that by reducing the diameter by 3 millimeters, we increased the stress by 41%. That's a big increase. That's a big increase. So you gotta be careful about this. Small changes can lead to big and sometimes drastically dangerous results. So just in summary, remember that we learned that we have to look for all the surface areas that are shown when our piece cuts or breaks, because shear stress is all about cutting. And so in this case, it was the area of 2 circles. So our area equation was not just pi over 4 times d squared, it was 2 times pi over 4 times d squared. And we also learned that we can calculate percent increase by taking the final value minus the initial value over the initial value, then multiplying it by 100%. I hope this helped you, and I look forward to seeing you in the next example. If you have any questions, please feel free to email me or contact me through some of the means. Have a wonderful day.